Good afternoon, class. We are going to start electrical motor control lab, Unit 2, Day 2. Okay. The objective is that the student and you guys as instructor learn how to show your student how to identify the magnetic motor controller and identify a push button, okay, and make all the connection for a magnetic starter. So we are going to be connecting a starter with a push button station to start a three-phase electrical motor. And that is the main objective for this lab. And of course, the equipment that we need a magnetic starter, we need a stop push button, we need a contactor. We are going to use a NEMA 0 contactor and a three-phase electrical motor. And of course, we need the wire, 14 gauge, THHN, and the wire stripper, flathead screwdriver, Phillips screwdriver, and also we are going to use the ammeter, multimeter, to be checking the electrical current. Additionally, I will be using the NEC to check on the table 430 250 the full load and capacity for the motor that we are going to be using. So, which is important to teach this part to the students. Okay, right here, we have this motor. It's a 1/4 horsepower, okay, three-phase. So 1/4 horsepower, and we are going to connect it to 220 volts, 208 to 20. Okay, this is for 480. We are going to use this one. And according to that, if I check on the NEC table 420.50, we don't have a 1/4 of horsepower, so I will use half. For half, connected to 208 is a 2.4 or 220, 2.2 amps. That is the full load and capacity that we are going to be consuming. And with this one, we can calculate, as we learned it during the first lab, how to calculate the protection using time delay, non-delay, fuse, dual element, and or circuit breaker. Okay. So, and we are connecting this one. Let me go over this. So this is, as I told you, is connected. If we check T1, T7 is connected to L1. Okay, T1, T7. T2, T8 connected to phase 2. And T9, T3, T9 connected to this one, connected to phase 3. And what we have here is a 1/4 horsepower three-phase electrical motor, okay, connected to a contactor. This is NEMA 0 contactor. The maximum horsepower that this can deal with is 5 horsepower. 5 horsepower. And that is the maximum, okay, NEMA 0. Okay, also it has this overload protection, okay, overload and phase out protection, because if it's overloaded more than 125%, the motor should be disconnected. Other than that, the winding on the primary, on the stator, the winding will be overheated, and eventually we are going to have a short circuit. The same happens when we have one phase out, because the other two phases will be overloaded, and as a consequence will be overheated, and the insulation material used by the electrical motor manufacturer to isolate each piece of copper on each winding will be deteriorated, will be lost. So that is the reason we need the phase out and overload protection. Okay, and in addition to this has one set of normally open contact, auxiliary contact. This contact number 2 and 3 is connected in parallel with 4 and 3. So when I start, if I don't use this contact and I release the start push button, the motor will stop. But in the way that I have it, when I press the start push down start, the contactor coil will be energized, and when it's energized, so this auxiliary contact will be closed and it will be in parallel with 3 and 4 and hold this energizer. In addition, we are using the terminal block. This terminal block maximum is 10 ampere, but we can order terminal block for different amps. This is for 10 maximum, okay? And because we are going to be consuming 2 ampere, we are fine over here, okay? And even though during the inrush, when we start the electrical motor, the 2.2 amperes could be 11 times the 2.2, that will be around 28 amperes, okay? So this is just for few seconds, few milliseconds, okay? So this is okay. This is okay. And we are using gauge number 12, the gauge number 12. Okay, let's test it. Okay. So, and before I test it, I forgot to mention this, we have two sections here. The control part and the power. The control part normally is also known as low voltage section, and this is the high voltage, okay? But keep in mind, high voltage for us is no higher than 600 amperes. So now let me close the circuit breaker on the panel, because we have a double protection. We have a circuit breaker and a fuse. Okay, so right here, 25, 27, 28 is closed. And then I close it. So I will test it now. So I will connect the power part and start. The objective is that the student learn how to connect a contactor that will be controlled by push button station, one push button station. This is manual control. It's manually, the operator has to come and stop the electrical motor, okay, stop the electrical motor or start the electrical motor. But it's very important here that we add some protection between the start and stop, a timer that provides time on delay, minimum 5 minutes, because if we are going to do this, start and stop over and over, the electrical motor, the stator on the electrical motor will be overheated, and as a consequence, we are going to have eventually a short circuit on the stator. Okay, so we need to take in consideration this, that we need to include a timer, time on delay. Okay. For example, it's stopping. If I start it now, I will be overloading the electrical motor, because the shaft is spinning in the opposite direction. Then I try to restart it, and the shaft will try to go on the clockwise, and it's stopping on the counterclockwise. So that will be an overload that I apply to my stator, in addition to the weight of the shaft because of the gravity. So it's important that we take in consideration this aspect. Okay, so that is what I have for today, guys. This is electrical motor control, and this is an example how to use push button station 1 to control a contactor, three-phase contactor to start and stop an electrical motor, three-phase electrical motor.